All right, so we'll look at empirical and molecular formulas and everything that is involved with the empirical and the molecular formulas. Okay, so an empirical formula, okay, if you define it, it's just the simplest, okay, the simplest um, formula that a compound or a molecule can have. Okay, so for example, I'll write two things here. So if I write C, okay, CH, and then let's say O. Okay, maybe I can put a 2 here, 3, and then like that. Okay, or let's put 6 here. Okay, so I have this formula here, and then I have another formula here that I'll write. Okay, so look at this formula. Okay, so I'll write 6, and then H, 36, and then O, 6. Okay, so between these two formulas here, there's one, a molecular formula, and two, there's an empirical formula. Okay, so you can see that this formula here and this formula are basically the same, but this formula here, okay, so here there has to be 18, not 36. So here there's 18, and then here there's 3. Okay, so you can see that these two formulas here are the same, but it's just that this formula here on the right has been multiplied by 3. Okay, so you can see this one at 2 here. If I multiply it by 3, I get 6. This is 6. If I multiply it by 3, I get 18. This here does not have any number, meaning there's a 1 there like that. I multiply this one by 3, I get 3. Okay, so this formula here that shows the simplest ratio of the atoms that make up the compound or the molecule is what we call as the empirical formula. Okay, the simplest um, chemical equation for a certain what compound. That's the empirical formula. And then the molecular formula is the one that will show the exact number of atoms that are contained in that what molecule. Okay, so it means, for example, in this molecule, there will be 6 carbons, 18 hydrogens, and 3 oxygens. But we can actually reduce this to the empirical formula that shows the simplest ratios of those what? Of those atoms. So that's what empirical and molecular formulas are. Okay, so now when it comes to finding these empirical formulas, okay, we always follow about, is it 5 or 4 steps? Okay, so let's say we want to find the empirical formula, okay, that contains elements A, okay, B, and then C. Okay, so the first thing is to write the elements that are in that compound. Okay, so you write the word elements here, and then full colon, and then here you're going to put A, B, and then C. Okay, so those are the elements that you have, right? Okay, the next thing there is to write their masses or their mass percent. So it doesn't matter if they give you the mass percent or the mass is going to be the same. So here you can say mass, okay, or you can just say mass percent. So whatever masses they will give you for these guys. Okay, so let's say, for example, the mass of A maybe is 5 grams. The mass of B, okay, maybe it's let's say 2, okay, 0.71. Okay, the mass of C, let's say maybe it's 1.71. Okay, so those are their mass percent or their masses. The third thing that you have to do is to find their moles. Okay, so how do you find their moles? So moles, okay, as we learned even in secondary school, moles is equals to the mass, okay, of a certain element over the what? The molar mass, right? Okay, so that's how we are going to be finding these moles here. So let's say the molar mass for this guy, okay, maybe it's let's say maybe 12.01. Okay, so that's my molar mass there. So you divide the mass by the molar mass to get the moles. Even here, I do the same. Okay, let's say the molar mass here is 1.01. Then here, let's say the molar mass for C is 16. Okay, so if when I divide all these by their molar masses, then I'm getting the moles. So let's get the actual values of these moles here. So the first one is 5 divided by 12.01. Okay, so that one will give me 0.4163. Okay, what about this one? So 2.71 divided by 1.01. So that one gives me 2.6832. And then what about the last one? That's 1.71 divided by 16. That one gives me 0.1, okay, 0.1, 0, and then 69. Okay, so be confirming these numbers on your own calculator as well. Okay, so once you find the moles now, okay, the next thing is to find the ratios. So how do you find the ratios? Okay, so you pick the smallest value for the moles, and then you divide all those moles that you have by that smallest value. So we see that here, this guy here is the smallest, right? So I'm going to divide this and this by this same value, which is the smallest. So I'll divide this guy. Uh, that should be in another row. Let me raise this a bit. Okay, so moles, and then from the moles we go to the ratios. Okay, so I'm going to say here ratios. Okay, so these ratios, how do we find them? We get the moles divided by the smallest moles that we have. So this will be 0.4163 divided by 0.1069. This will be 2.6832 divided by 0.1069. This one will be 0.1069 divided by 0.1069. Okay, so what are we going to get their values? Okay, so the first one I have 0.4163 divided by 0.1069. So that one gives me a 3.8943. What about this one? So that one is 2.6832 divided by 0.1069. Okay, so when I divide this 0.1 into this, it gives me 25.1001. Okay, what about this one? This one is the same thing. Okay, so we're dividing by the same thing. So the answer there is just 1. Okay, so the answer is that one. So the ratios are these guys that are found there. Okay, so there's 3.89 something. Okay, 25.1, 0 something, and then 1. Okay, so here we'll just simply round this off. Okay, so if I round off this guy, I'm just going to get 4. If I round off this guy, I'll get 25. If I round off this one, it's just 1. So this one is for A, this one is for B, this one is for C. So it means your empirical formula will just be A4, B 25, and then C 1. Okay, but the one we don't show it. So we remove it like that. So this one here will be your empirical formula. Okay, so those are always the steps that we need to take when you're finding the empirical formula. Okay, where there will be some work to do is how to find this mass percent or these masses here. That's where there will be some work. In some questions, they'll give you direct the masses, so just go straight to the process. Okay, but in some questions, you need to find these ones here. Okay, so you really have to know how to find these values here. All right, so any questions there on how to find the empirical formula? Okay, we are going to solve actual questions. I'm just giving a general overview here so that you just know the process, and then now we start the actual questions. Okay, so if there are no questions, another thing that you have to know is when to round off. Okay, when to round off. So you can see those numbers that I found there. This was the 3.8943, right? And I rounded it off to 4. This one here was 25.1001. I rounded it off to 25. And then this one is just a whole number, so there's no need to round it off. Okay, so there are specific times when you round off, and other times you can't round off. Instead, you're going to look for a number such that when you multiply all the ratios, okay, it gives you a number that you can round off, okay, or it gives you a whole number. So the limiting case is here. So I'll draw something like a number line here. So here I'll put x.2, and then here I'll put x.8. Okay, so I'll draw a line here, I'll draw a line here. So you can only round off, Okay, you can only round off if the number that you have after the point, there's a number that will be greater than 2. I mean, that will be less than 2. So for example, if I have x point 1, so in short, this x can represent any number. Like in this case, the x will be 25.100. So you see that the number that comes after the point, 0.100, is actually less than 0.2. So it's somewhere here. Okay, so if it's somewhere there, then you're allowed to round off. Okay, and again, if you get a number, okay, such that after the point you have a number that will be greater than 9. For example, this one here, this is 3.8943, like that. Okay, so if I write x point 8 here, this x here, in this case, it's this 3 here. So x can be any number. So here it's just 0.8, here it's 0.89. So which one is bigger between 0.8 and 0.8943? This 0.8943 is bigger, okay? So it means that value here, it's somewhere here after the 8 point what? After the x point 3, I mean. So it means that we can round off. So we can only round off if a number after the decimal point is less than 0.2, okay? Or if the number after the decimal point is greater than 0.8, okay? If it's in between here, we can't round off. Never round off. Otherwise, you're going to find the wrong empirical formula. So what then do we do to numbers that are between x point 2 and x point 8? So for example, if you get maybe your number, okay, you get 1.3, 4, and then 5. You see that after the point, I have 0.3, right? So 0.3 will be somewhere in between here, right? So I can't round off this guy here. Okay, I can't round off this guy when you're finding the empirical formula. Otherwise, you're going to find the wrong empirical formula. So what do you do to such numbers? You look for a number such that when you multiply this number here, it's going to give you a number that will be in this range so that you can be able to round off, or it's going to give you a whole number. Okay? Right, so that's what we do. So there are about 3 categories of numbers that are not rounded off, and then we look for something to multiply them with. So if you have a number that has 0.3 something, like this one here, you always multiply by 3. Okay, so you multiply all the factors, not just that number that you are failing to round off. All the factors or all the ratios that you found, you multiply by this number here. So if it has 0.3 something, you multiply by 3. So for example, if I multiply this number by 3, what am I going to get? So 1.345, multiply it by 3. Okay, if I multiply this by 3, I get 4.035. So you've seen that after the point, now I have 0.0, which is less than what? 0.2. So it will be in this region here, so we can actually what? Round it off. Okay? What if I have a number 1.257? Okay, so if you have 0.2 something as your number, okay, the most convenient number to multiply with will be 4. Okay, so we try to multiply by 4. So whenever you see just you have something 0.2, multiply by 4. So if I multiply this number by 4, what do I get? So 4 multiplied by 1.257. Okay, I'll get 5.028. So you see that 0.0 is less than 0.2, so I can round off this number. Okay, so that's what you should always be doing when you find a number that is between these two here. Another one is when I have maybe 0.6. Okay, so you have whatever number can be here, but it's 0.6 something. Okay, so if you have 0.6 something, again, you multiply by 3. Okay, you multiply by 3. So if I multiply this number by 3, you see what I'm going to get. So 3 multiplied by 1.68, I get 4.89. So the 0.89 here is greater than 0.8. So it's somewhere here. So we can round it off. Okay, we can round it off. So you either get a number that has 0.3, okay, 0.6, you multiply by 3. If you have 0.2, you multiply by 4. And then there are some cases where you have 0.5. So for example, I have 2. Maybe 5, 6, 7. you can see this is 0.5. So 0.5 is between the 0.2 and 0.8, right? So this one, we can't round it off. So if the number is 0.5 something, you multiply by 2, okay? You multiply by 2. So if I multiply that number by 2, what do I get? So I have 2.567 multiplied by 2. Okay, I'll get 5.134. So now you see this is 0.1, which is less than what? 0.2. So it's somewhere here. So I can round it off. Okay, so don't round off anyhow. Okay, follow these rules that I'm talking about here. So for example, now, okay, I want to give an actual example. If, for example, the ratios after you find your empirical formula, after you go through all those steps, okay, for example, the ratios now are something like this. Okay, so let's say the first one is 1.357. Okay, and then the other one is 2.0074. Okay, and then the other one is maybe 4.671. Okay, so if you get such ratios, you don't round off like this here, okay? Because this one here, you can't round off. This one, yes, you can round off because this is just 0.0, which is less than 0.2. This one is 0.6, this one is 0.3, so they are in between here, so we can't round them off. So we said if you have 0.3 something or 0.6 something, you multiply by what number? 3. So we're going to multiply all these ratios here by what? 3. So this one becomes 1.357 multiplied by 3. I get 4.071. This one, okay, it's 2.0074 multiplied by 3. I get 6.022. And then this one, 4.671 multiplied by 3. Okay, I get 14.013. So you can see now that the numbers that we have, this 0.0, 0.0, 0.0, which is just all less than what? 0.2. So we can round them off. So this will be 4, this will be 6, this will be 14. So that's how you know when to round off and when not to round off. Okay, so any questions there on that concept of the rounding off? Because it's going to appear a lot as we'll be solving the questions. Okay, so if there are no questions, you've known now when to round off, okay, when you have those ratios, right? Okay, so the other thing now is how do you convert now your empirical formula to a molecular formula? Okay, so you always use this formula. So molecular formula, okay, is equals to the empirical formula multiplied by a factor n. Okay, so this factor n here is equals to the molar mass, okay, of whatever compound you are finding the empirical formula for. So your molar mass there, and then you divide by the empirical formula mass. Okay, so empirical formula mass. So for example, if my empirical formula may be CHO, okay, CHO, just an example. If this is my empirical formula here, right? Okay, so from this empirical formula, I'll get my empirical formula mass, simply meaning add the molar mass of this guy to this guy to this guy. So for the carbon, we know it's 12.01. You get it from the periodic table. Plus the hydrogen is 1.01. Plus the oxygen is 16. So when I add all this to find my empirical formula mass to be 12.01 plus 1.01 plus 16. So my empirical formula mass will be 2902. Okay, so this is my empirical formula mass. And then this molar mass here, you'll be given in the question, or you'll be given information that will help you find the what? The molar mass. So let's say now, for example, the molar mass was as given as 87.03. Okay, let's say, for example, this was my molar mass. So I can now easily calculate my N there. So my N will be the molar mass, okay, divided by the empirical formula mass. So when I divide this, I'm getting 3. So it means my N is 3. So it means my molecular formula in this case will just be equals to, you put your empirical formula here, and then multiply by 3. So this will just be C3, H3, and then O3. Okay, so this is just an example, but there is no compound that exists like that. So that's how we are going to be finding the what? The molecular formula. Okay, so I've explained everything, how to find the empirical formula, when to round off, and how to find the molecular formula. Okay, so the rest now is just questions. Okay, and we're also going to look at mass percent, and then the last thing that we'll look at will be combustion analysis. So still finding the empirical formula, but using combustion analysis. So let's begin with just the empirical formula question. So this is an actual exam question that can come in your tests, in your quiz, or in your exam. So this question is saying, okay, vitamin C, also known as ascorbic acid, contains 40.92% carbon and 4.58% hydrogen. And the remainder is oxygen. Okay, so we have this compound here, vitamin C, which is also known as ascorbic acid. So it has this amount of carbon, this amount of hydrogen, and the rest, they're saying it's what? It's for oxygen. So we all know that a percent is always out of 100, right? Okay, so meaning that if I add the percent for carbon, the percent for hydrogen, and the percent for the oxygen that they haven't given us, I should get what? 100%. Okay, so that is what is going to help me find the percentage composition of this oxygen here. So I'm going to say, okay, 40.92% for the carbon plus 4.58 for the hydrogen plus the percent for the oxygen. I should get what? 100%. Okay, so now I want to find the percent for the oxygen. So percent for the oxygen will just be 100. Then you take these guys to the other side. So if you want, you can first sum them, and then you take the sum to the other side. So 40.92 plus 4.58. And then I take it to the other side. So it gives me minus 45.5. Okay, so that would be 100 minus 45.5. So that one gives me a 54.5%. Okay, so meaning the oxygen here has a 54.5%. Okay, and then they're asking us to find the empirical formula. Okay, so the empirical formula, we follow the same steps that are outlined. Okay, so we said element here. So element, we have carbon, hydrogen, and oxygen. So I'll put carbon, hydrogen, and then oxygen. Okay, and then here I'll put mass percent. So the mass percent for carbon is 40.92. For the hydrogen, it's 4.58. And then for the oxygen, it's 54.5. Okay, so what is next here is to find the moles, right? Okay, so the moles, we're going to divide each of these here by their molar masses. Okay, so the molar mass for carbon is 12.01 grams per mole. So you get these values from the periodic table. I'm going to show you. For hydrogen, it's 1.01 grams per mole. Then for oxygen, it's 16.00 grams per mole. Okay, so if I go to this is a periodic table here. So if you want to find like the molar mass of carbon, okay, you follow the key here. So they're saying there's on top, there's element name, atomic number, meaning number of protons, then the symbol for that element, and then the atomic mass. So this atomic mass here is the one that we are calling as the molar mass. Okay, so if I go for the oxygen, this is the oxygen, for the carbon here. The molar mass or the atomic mass is this guy which is down there. So you can see there's 12.0107. Okay, so all the atomic masses there are to 4 decimal places or to 3 decimal places. But what we are going to be using in our equation is the one that we round off to 2 decimal places. So this guy here, if we round it off to 2 decimal places, it's just going to give you 12.01. That's what we are going to be using. For the hydrogen, it's this guy here. That is 1.00794. So we round off this guy to 2 decimal places. That's where the 1.01 is coming from. Okay. And then for the oxygen, you can see there's 15.9994. So we round this off to 2 decimal places. Okay. If I round off this 9, this will be 10. So I write 0, carry the 1 here. It will be 10 again. I write 0, carry the 1 here. So that's why I get 16.00 like that. So that's how we find the molar masses from the periodic table. Okay, so these are the ones that I wrote here. So I'm just going to divide each of these here, okay, by their molar masses. So I'll just do it on the calculator and then write the moles here. So for the carbon, it's 40.92 divided by 12.01. Okay, so the numbers that I'm getting on the calculator, I'll be writing them to 4 decimal places. So the moles here, when I divide this by 12.01, it's 3.4072. So try it on your calculator as well. This one, 4.58 divided by 1.01. So that one gives me 4.5347. Okay, what about the 54.5 divided by 16 for the oxygen? That one gives me 3.4063. Okay, so those are the moles. And then now I ask myself, okay, because the next thing is to find the ratios. I ask myself, which one of these numbers here is the smallest? Okay, so this is 3.4072. This is 3.4063. So this one is the smallest. So I'm going to divide all these by this number here, which is the what? The smallest. Okay, so I won't show the writings here, but I'll just be dividing on the calculator. So this guy here, I divide by this because this here is the smallest. Okay, what am I going to get at my ratio? So 3.4072 divided by 3.4063. So do it also in your calculator. I'm finding 1.0003. What about this number if I divide him by this? So that is 4.5347 divided by 3.4063. Okay, so there I get 1.3313. And then this one, if I divide it by itself, I'm just going to get 1. Okay, so these are the ratios that I have. Okay, so now the issue of rounding off comes in. Okay, so remember we can only round off, okay, if something is less than x.2 or it's greater than x.8. That's when we can round off. Okay, so this one here we can round off because the 0.0 here is less than 0.2, so this will just be 1. This one here I can't round off because it's 0.3, which is greater than 0.2 but less than 0.8, so it's somewhere in between here. So this I'll write it the way it is. Then this one is just 1. Okay, so we said if it's 0.3 or it's 0.6, we multiply by what number? 3. So I'm going to multiply all these factors by 3. So this one will be 3. This one here, okay, let me do it on the calculator. So 1.3313 multiplied by 3, I mean. It gives me 3.9939. Then this one here is still 3. Okay, so you see now that the number that I have here, I can round off this guy here because it's greater than what? X.8, because this is 0.9. So I can round off that. Okay, so it means my ratios there will just be, okay, my ratios there will just be, this one will be 3. This one, when I round off, it will be 4. Then this one still remains 3. Okay, so that will be my empirical formula there. It should just be C3, H4, and then O3. So this is my empirical formula here. Okay, so any questions there, guys? Okay, so if there are no questions, we move forward. So let's look at another example. So here we're finding the empirical formula as well as the molecular formula. Okay, so let's read the question. So here they're saying a white powder is analyzed and found to contain 43.64% phosphorus and 56.36 oxygen by mass. Okay, The compound has a molar mass of 283.88 grams per mole. Determine the empirical formula of the compound, okay? And then again, determine the molecular formula. Okay, so what we're going to do there is the same thing that we did on the previous question. Okay, it's the same thing that we did on the previous question. All right, so here we have to make sure first of all that these percentages here add up to 100. So you try adding them and then you see. So 43.64 plus 56.36. Okay, so it gives me 100%. Okay, so if you're satisfied that it's 100%, then you can start finding your empirical formula now. So as usual, we're going to say element here. Okay, so we have phosphorus and what? Oxygen. So I'll put phosphorus here and oxygen. And then I'll put mass percent. Okay, so the mass percent is 43.64 here. Here it's 56.36. Okay, from there I find the moles. So meaning I'm dividing this mass percent with the molar masses of phosphorus and what? Oxygen. So oxygen, its molar mass is 16.00. What about phosphorus? So if you don't know, you just come to your periodic table and check. So phosphorus is here. Where is it? Is here. That's phosphorus there. So it has 30.97376. So you round off to 2 decimal places. So that would be 30.97 like this. Okay, so that's what I'm going to use there. 30.97. So 30.97. So I'm going to divide this guy, okay, by 30.97. So 43.64 divided by 30.97. So that one gives me 1.4091. Okay. The other one is 56.36 divided by 16. That one gives me 3.5225. Okay. So you can clearly see that here, the smaller number here is the 1.4 something. So to find the ratios, I'll just divide everything by this. So if I divide this by itself, I'm going to get 1. What about if I divide this, okay, by, if I divide that by 1.4091. Okay, so that one is going to give me 2.4, okay, 998. Okay, so that's what I get. So I see that this one is just normal, but this one here is a decimal. So this decimal here, if we write our scale, this is x.2, x.8. So you see that x.4 is somewhere in between here. So we can't round it off. So we look for a number such that when we multiply this, okay, we get a number that is a whole number or something that we can round off. So we see here that this is 1 and this is 2.4 something. Okay, so we have 2.499. This number is close to 5, right? Okay, remember I said if we have something 0.5, we multiply by 2. So this is very close to 5. So I'm going to multiply throughout by 2. So if I multiply throughout by 2, this guy here, it gives me 2. Okay, and then this one will give me 4.9996. Okay, so now we see that we can actually round this off because the 0.9 is greater than the 0.8. Okay, so those will be my ratios there. So let me just round them off. So this remains 2. This one becomes 5 like this. Okay, so the empirical formula will simply be P2O5. This is the empirical formula. Okay, that's the empirical formula there. All right, so found the empirical formula. So let's write it here. So P2O5. That's my empirical formula. The next thing is to find the molecular formula. Okay, so it's not hard. I just have to find the empirical formula mass. So empirical formula mass, it will come from this. So it will be 2 multiplied by the molar mass of phosphorus, which we found was 30.97, right? Here, 97. And then I'll say plus 5 multiplied by the one for oxygen, which is 16. So this will give me what? So I'll just do that on my calculator. Okay, so it will be 2 multiplied by 30.97 plus 5 multiplied by 16. So that gives me 141.94. So this is my empirical formula mass. So I just have to find that factor now. So that factor is molar mass, which is 283.88 divided by empirical formula mass, which is 141.94. So what do I get? Okay, so 283.88 divided by 141 and then 0.94. Okay, so when I do that, I get 2 exactly. Okay, so that will be my factor. So it means now my molecular formula will just be equals to the empirical formula multiplied by the factor, which is 2. So this will just give me P4 and then O10. Okay, so that is my molecular formula there. Okay, so any questions there, guys? We found our molecular formula there. Okay, so let's move. We look at another question, okay, again on the empirical formula so that what we know just sinks in our heads. So there, it's very simple here because we've been given the percent of everything that is contained in that element, compound. So determine the empirical formula for a compound containing this percent of carbon, oxygen, and chlorine. So I'll just say element here. Okay, so the element is carbon, oxygen, and chlorine, and then mass percent. Okay, so the mass percent I have 12.14, 16.17, 71.69. Okay, and then I find the moles. So the moles, I just have to divide by the molar masses of these compounds here. So for carbon, it's 12.01. For oxygen, 16.00. For chlorine, it's 35.45. Okay, so let me divide. So if I divide this by that, I get 1.0108. If I divide this one by 16, okay, I get 1.0106. And then if I divide this by 35.45, check on your calculator, I'm getting 2.02. Okay, so which one is the smallest amongst these numbers? We see that this guy here is the smallest. Okay, this guy here is the smallest. So I'll divide throughout by that to get the ratios. Okay, so you punch on your calculator. Okay, so if I divide this guy into this, okay, I'm getting 1. 1.000, there are a lot of zeros, so I'll just write 1. If I divide this one by itself again, I get 1. Okay, if I divide this guy by this, I get 1.998. Okay, so can we round off this? Okay, this one stays the same. This one stays the same. This one, yes, we can round off because I have 0.9 here, which is greater than x point what? 8. So, hey, what has happened? Okay, so this one will round it off to 2. So it means our empirical formula will be C1, O1, and then Cl2. But we don't show these to my ones, so it will just be CO, Cl2. So that's the empirical formula there. Okay, so any questions there, guys? Yeah, so these things are easy. Okay, these things are easy. You just have to pay attention to whatever is happening. Okay. All right, so we've talked about how to find the empirical formula, We've even solved some examples. So now I'll go to another concept, which is percentage composition. Before we go to combustion analysis, I want to talk about percentage composition. Okay, so percentage composition It's very simple, okay? So in basic terms, it's just a percentage. So for example, when you be given a test, okay, or when you are writing the exam, that test will be out of 100%, right? Okay. And then whatever you are going to get out of the 100, okay, those will be your marks. So those marks of yours are the percentage composition. Okay. It's just simply what you got over the total that was given. So the total they gave you, the lecturers will be giving you 100 free marks. Okay. But it's up to you now to earn, okay, some of those marks. So maybe you get 70 out of 100. That will be your percentage composition of the 100 marks that your lecture what gave you. All right. So now when it comes to compounds or when we come to chemistry, okay, when we're finding the composition or the percentage composition, we're simply just finding how much, okay, of an element is in a certain compound. Okay, that's the percentage composition. Okay, so for example, if I get water, which is S2O, and then I want to find the percentage composition of the hydrogen, I'm just simply finding out what percent, okay, of the mass of water is hydrogen. That's what I'm finding. That's the percentage composition. Okay, so how do we find it? We divide the mass of the atom, okay, that we want to find the percentage composition for, divided by the total mass of the compound where it's coming from. So if, for example, I want to find the percent composition of hydrogen here, okay, I'll say the mass of the hydrogen, okay, which is present in the water, I can see 2H there, and then divided by the mass of the entire compound, which is water, and then multiplied by 100. So whatever answer that I'm going to get here, that will be the percent composition or the percentage composition for the what? For the hydrogen in water. Okay, so you have to know the percentage composition, okay, when it comes to questions that involve combustion analysis. Okay, no wonder I've put it here so that we can talk about it. And then later on, we're going to use it. You're going to see how we are going to be using it. Okay, from here, we're going to draw some facts that we'll be using in later questions. So, the first question there, okay, they're saying calculate the percentage composition by mass of each element in water. So in water, there is the oxygen and hydrogen. Okay, so here, because we haven't been given any masses, we are going to use the molar mass. So meaning those masses we got from the periodic table, right? So we said the molar mass of hydrogen from the periodic table, rounded off to 2 decimal places, was 1.01, right? And then grams per mole. For oxygen, we found it was 16.00 grams per mole. Okay, so meaning that if I want to find the molar mass of this whole compound, which is water, I'm just going to say 2 multiplied by 1.01 because I can see 2 hydrogens and then plus 1 oxygen. So this gives me 18.02 grams per mole. So this one here is the molar mass of the water. Okay, so now if I want to find the percentage composition of hydrogen, okay, in water, I'm going to say the molar mass or the mass of hydrogen that is contained in water. So what is the mass of hydrogen that is contained in water? I can see 2 hydrogens in water. So it will be 2 multiplied by the molar mass of hydrogen. So if I do 2 multiplied by this, I'll just get 2.02. So in water, okay, of this 18.02, 2.02 is for the hydrogen. Okay, so percent of the hydrogen will just be 2.02 divided by the total for the water, which is 18.02. And then I multiply by 100. So what am I going to get here? Okay, so it will be 2.02 divided by 18.02, and then I multiply by 100. So what I'm going to find here will be 11.20976693%. Okay, so this percentage, we're going to round it off to 1 decimal place. So that will be 11.2. So 11.2%. Okay, so this tells you that of any mass of water that you've been given, okay, of any mass of water that you've been given, 11.2%, okay, of that mass is going to be for the hydrogen. Okay, so for example, now if they say maybe in a chemical reaction, water had a mass of 2.5 grams, find the mass of hydrogen. You're just going to multiply this percent with the mass of the water that you've been found. Because from here we have, okay, found that 11.2% of every mass that you can be given of water is going to be hydrogen. So to find how much of this 2.5 is hydrogen, I'm just going to say 11.2 over 100. This means percent, okay? And then multiply by whatever mass that I've been given. So the mass that I'm going to find here will be the mass of hydrogen in this what? 2.5 grams of what? Water. So this is a fact that we have to be using when we are finding the empirical formulas for those questions that we have combustion analysis. Okay, so we can put this fact somewhere there. So we can say 11.2%, okay, of any mass of water is hydrogen. All right, so we found the mass percent of hydrogen. What about the mass percent of oxygen in water? Okay, so let's say percent of oxygen. So percent of oxygen, there's just one oxygen there. Okay, so what is the mass of that oxygen? 16. So that would be 16 multiplied by 100. So 16 divided by 18.02, then multiplied by 100. So that one gives me 88.7902. So I'll just round it off to one decimal place. It will be 88.8%. Okay, so for any mass of water, 88.8% will be the mass of oxygen. And then 11.2% will be the mass for what? Hydrogen. Okay, so know this fact, especially this one for hydrogen. The one for oxygen is not important, but the one for the hydrogen is important because we'll be using it in combustion analysis. Okay, so we found the percent composition of this water. It is made up of 11.2% hydrogen and 88.8% what? Oxygen. All right, so what about carbon dioxide? Let's talk also about carbon dioxide because it's there in combustion analysis. So carbon, okay, we said its molar mass is 12.01. Then oxygen is 16.00. Okay, what about carbon dioxide? So in carbon dioxide, we see we have two oxygens. So that would be 12.01 plus 2 multiplied by 16. So this will give me 44. Okay, to give me 44.01 grams per mole. So this is the molar mass of carbon dioxide. Okay, if you want, you can memorize it so that you don't have always to do this. All right, so let's find the percent composition of the carbon to just be the carbon that is that carbon dioxide is just 12.01 divided by the mass of the whole carbon, which is what? 44.01. Then I multiply by 100. So what am I going to get? So 12.01 divided by 44.01. Okay, then I multiply by 100. So I'm finding 27.3892524. So I'm just going to round this off to one decimal. Oh, this one here is 2. What did I write? 3. I'm going to round it off to one decimal place. So I'm just going to say 27.3%. So again, this is a very important fact when you are talking about combustion analysis. Okay, so 27.3% of any mass of carbon dioxide, okay, is going to be carbon. So if they say, for example, the mass of carbon dioxide is 5.0 grams, okay, then 27.3% of this 5.0 grams is going to be carbon. So to find the mass of carbon in these 5 grams, you're just going to say 27.3% multiplied by 5. So whatever answer you're going to find here, that will be the mass of carbon okay, in 5 grams of carbon dioxide. So this one is very important, like just like the one for the hydrogen. So I'm going to say here, so this was in water. And then now in carbon dioxide, we are concentrated on the carbon. It has 27.3%, okay, for the carbon. So very important, this one. So these two, are going to be using them in combustion analysis. Okay, let's also find the percentage composition of oxygen in carbon dioxide. So oxygen, you can see in carbon dioxide, we have two of it because it's CO2. So there's two. So I'll say 2 multiplied by 16. So that would be 32 over 44.01 multiplied by 100. So that will give me 32 divided by 44.01, then multiplied by 100. So that gives me 72.71074756. So this is simply 72.7%. Okay, so the percentage, okay, of the oxygen in carbon is simply 72.7%. Then for the carbon is 27.3%. The one which is important is the one for the carbon. We can forget the one for the oxygen. All right, so that's how we find the percentage composition. I've also put some other questions here that you guys can try out on your own. So you try out this one, just finding the percentage composition of this. So you find how much the percent of hydrogen here, the percent of sulfur, the percent of oxygen. Okay, even here for the glucose, you can find the percentage of carbon, percentage of hydrogen, percentage of oxygen. So you can even take a screenshot of this so that you try it out at your own time, and then you can send the questions to me. I'll be able to guide you if you're doing the correct thing or you need some improvement. All right, so having known the percentage composition now, let's talk about combustion analysis, because next we'll be solving questions on combustion analysis. You can see this is combustion analysis question. So when we talk about combustion analysis, okay, it's a very simple concept. So combustion in chemistry, okay, when you hear combustion, it simply means burning. Okay, it simply means burning in oxygen. Or in other words, it simply means reacting something with oxygen. That's combusting. Okay, so combustion analysis is just these hydrocarbons, okay, or organic compounds reacting with oxygen. That's what combustion analysis is. Okay, so don't be intimidated by the word combustion analysis. Oh, what is combustion? No, 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 no. Combustion analysis is simply a hydrocarbon or okay, an organic compound. Most of the times it's going to be an unknown organic compound, okay, that you're trying to determine the formula for. It's just reacting with the oxygen. That's what combustion analysis is. Okay, so let's say, for example, our known organic compound is X. Okay, so this X is reacted with oxygen. This is what we call combustion analysis. Okay, so what will be produced here when an organic compound reacts with oxygen will always be, okay, water and carbon dioxide. Of course, there can be some minor products, but the major products that we are going to be focusing on mostly will just be carbon dioxide and water. Okay, so whenever an organic compound reacts with oxygen, water, carbon dioxide is produced. Okay, yeah, so that's what happens in combustion analysis. So now, the amount of carbon in this unknown organic compound, okay, is equal to the amount of carbon that goes on to form carbon dioxide. And the amount of hydrogen in this unknown hydrocarbon is equal to the amount of hydrogen that goes on to form the water there. Okay, simply meaning that all the carbon that was in this unknown organic compound, okay, goes on to form carbon dioxide. And all the hydrogen that was in this unknown carbon compound, I mean organic compound, goes on to form what? Water. That's what I mean. So in the questions, they're just going to be giving you the mass of this and the mass of this. Okay. And then since they have given you the mass of this, we are just from learning percentage composition. We can use percentage composition to find out how much of the carbon dioxide is carbon and how much of the water is what? Hydrogen. And then if I manage to find the amount of carbon here and the amount of hydrogen here, it indirectly means I've found the amount of carbon here and the amount of hydrogen what? There. Because we said the carbon here is equal to the carbon there, and the hydrogen here is equal to the hydrogen there. That's what it means. Okay, so this is the whole process of combustion analysis. Okay, so we're just going to be using the masses for the carbon dioxide and the masses for the water to find the mass of carbon, okay, and the mass of hydrogen. And then once we have those, it means we know the mass that was in the unknown organic compound. Okay, so most of the times, this unknown organic compound is going to be a hydrocarbon. Okay, most of the times. So we know that a hydrocarbon, just from the name, contains carbon and hydrogen only. That's why it's a hydrocarbon. Okay, but there are some rare cases. Okay, I'm hoping I've put equations like that, that has that. Okay, there are some rare questions where the unknown organic compound also contains other minor compounds like oxygen, sulfur, nitrogen. Okay, yeah, so that's how we'll be moving in what? In combustion analysis. Okay, so let's try out this question here. Please, guys, if you have any questions, ask me so that you get to learn how to do this. Because definitely, test one, you're going to find a question like this. Okay, and it will be very bad if you fail to answer that when you have stressed here that you should know it. Okay, so if you don't understand, please ask me so that I explain again. All right, so here, question 4, they're saying a compound contains carbon and hydrogen only. So meaning it's a hydrocarbon. Okay, so on combustion, or in other words, when it reacts with oxygen, that's what they mean. Okay, on combustion or when it reacts with oxygen, the compound produces 0.488 grams of carbon dioxide, okay, and 0.15 grams of water. The compound has a molar mass of 52.0 grams per mole. Calculate the empirical formula, calculate the molecular formula. Okay, these are free marks in the test. So what you are going to do here is you have to find how much of the carbon is, how much of the carbon dioxide is carbon, how much of the water is hydrogen. So remember now the percentage that we found here. Okay, I said these ones are very important. So any amount of water has 11.2% hydrogen. Any amount of carbon dioxide has 27.3 carbon. So I'm going to use that. So I'm going to say, okay, mass of carbon, we're just going to be equals to the percent of carbon, which is 27.3 divided by 100 multiplied by the mass of carbon dioxide that I've been given, which is just 0.488 grams. Okay, so this is just going to give me the mass of carbon. So that is 27.3. Okay, 27.3 multiplied by 0.488 and then divided by 100. Okay, so I'm going to find the mass of carbon to be 0.1332 grams. So this is the mass of carbon. Okay, so I can write here, carbon has a mass of 0.1332 grams. Okay, what about the mass of hydrogen? Okay, so hydrogen, 11.2% of it, okay, and then multiply by the mass of water, which is 0.150 grams. So if I multiply this on my calculator, I'm getting 0.0168 grams. So this is the mass of hydrogen there. Okay, that is the mass of the hydrogen there. All right, so that's what I have there. Okay, that's what I have there. So let's now find the empirical formula because I have the mass of the carbon and I also have the mass of the what? Of the hydrogen. So hydrogen simply 0.0168 there. Okay, so now since we have the masses of carbon and hydrogen, we can easily find the empirical formula, right? So the empirical formula, as usual, we start with the element. So we have carbon and hydrogen only. And then here we put mass percent or the mass. So in this case, we have masses. For all those questions that we did, we had the mass percent. So here I'm just going to write mass. Okay, so mass percent is the same. So the mass here is 0.133 and then here the mass is 0.0168. Okay, so from there I find the moles. So the moles will be 0.1332 divided by 12.01, 0.0168 divided by 0.016. Oh, what am I doing here? The molar mass of hydrogen is 1.01. Okay, so the ratios that I'm getting there for this one, if I divide, I'm getting 0.0111. Okay, and then what about this one? Okay, so when I divide this one, um, what most am I getting there? Okay, I'm getting 0. Um, 0. I'm getting a similar answer. Okay, so 0.0166. Okay, so those are the moles that I'm getting. And then from the moles, we go to find the ratios now. Okay, so the ratios, we look at which one of these two is the smallest number. So we see this is 0.11, this is 0.0166. So this one is bigger, this one is smaller. So we're going to divide throughout by the smaller number, which is this one. So this one divided by itself, I'm just going to have 1. And then this one divided by this, what do I get? So 0.0166 divided by 0.0111. So I get, okay, I get 1.4954. Yeah, that's 5, not 4, 5. So that's what I get. So can we round off this guy here? Okay, according to what we have learned? No, we can't, because this is x.2, this is x.3. So this 0.4, it's somewhere in between here, so we can't round it off. Okay, but this is 0.49, so it's closer to the 5. So we said if we have 0.5 somewhere there, okay, or 0.49 somewhere there, we always multiply throughout by what? 2. So I'm going to multiply here throughout by 2 so that I get here 2. Here, I'm going to get what? Okay, so 1.4955 divided by, multiplied by 2. So I'm going to get 2.991. So this 2.9 is greater than 0.8. So it's somewhere here, so I can round it off. Okay, so it means my empirical formula here is just going to be, okay, this will be 2 still. This one I can now round it off, it will be 3. So that will be my empirical formula there, to just be H2, C2H3. Okay, so that is my empirical formula. The next step is to find the molecular formula. Okay, so the molecular formula, what do? We first have to find the empirical formula mass. So empirical formula mass will be 2 multiplied by 12.02 for the carbon plus 3 multiplied by 1.01 for the hydrogen. So this one gives me what as my empirical formula mass? Okay, my calculator says 27.05. Okay, so I can find my factor, which will just be the molar mass, which was given here. So that is 5.0 and then grams per mole divided by 27.05 grams per mole. So what do I get as my factor? So 52.0 divided by 27.05. So I get 1.922366599. So I can round this off now to 2. So the factor is 2. So it means my molecular formula will simply be the empirical formula multiplied by the factor. So I get C4H6. Okay, so that is my molecular formula. So any questions there, guys? Any questions from there? Okay, I hope you guys are understanding. Let's solve the last question. So this is the last question for today. So again, this question is on combustion analysis. Okay, but this one has a nice trick that that most students they don't see it, and then they end up failing. So they can know the whole process that we've been doing. Okay, but when the question comes like this, they actually fail it. Why? Okay, because they don't have the knowledge of how to convert units. Okay, so those molar masses that we get from the periodic table, remember, their units is grams per mole. So meaning that whenever you're solving these questions on combustion analysis, if you have been given the mass, always change that mass to grams. Okay, so this is where the most students miss it because they want to change the mass to grams. They'll just find like that and then they'll not find the correct thing. Okay, so if you've been given mass in any other units, change it to grams. No wonder we did that first topic where we're doing unit conversions. Okay, we'll be now using it. Okay, so they have combined it now with this combustion analysis question. Because you can see here the masses have been given in milligrams, milligrams, milligrams. So if you don't know how to convert from milligrams to grams, then you are gone. You're, you're going to get this question wrong. Okay, so no wonder you have to know how to convert units, that first topic that we did. So if you didn't know, or you thought we were just playing when we were doing that, go back to that video, watch it. Okay, know how to convert the units. So here we have to convert all the units to milligrams. I mean to grams because they've been given in milligrams. So anyway, let's read the question. So they're saying here, a certain acid, okay, known as terephthalic acid, okay, contains carbon, hydrogen, and oxygen. Okay, combustion of 19.81 milligrams of this acid produces 41.98 milligrams of carbon dioxide and 6.45 milligrams of water. Determine the empirical formula of the acid. Okay, if 0.25 moles of terephthalic acid has a mass of this, determine its empirical formula. I mean, its molecular formula. Okay, so before you start doing anything here, okay, just convert the masses to grams. Okay, so we did two methods. We did conversion by dimensional analysis, and then we did conversion by metric system. So here we're going to do metric system. So remember, when we have milli, it's the same as 10 to the power minus 3, okay, from the metric table. Those who have been following all the classes, they know. So this one here is 19.81 milligrams. So I'm just going to say this is the same as 19.81 multiplied by, I replace this milli here with its value, which is what? 10 to the power minus 3 grams. Okay, and then I can punch this on my calculator so that I just get a decimal number. I am going to get 0.01981 grams. Okay, so that is this guy. It's just 0.0181981 gram. Okay, so if I convert this one, it will be 41.98 milligrams. It will be the same as 41.98 multiplied by 10 to the power minus 3 grams. Okay, I've just replaced the milli. I write this as a decimal. Okay, so I just punched whatever I can see here on the calculator. It's going to give you 0.04198 grams. Okay, I'm only remaining now with this one. So that is 6.45 milligrams is equals to 6.45 multiplied by. So this M here is 10 to the power minus 3 and then grams. So if I multiply, I'm getting 0.00645 grams. Okay, so I've converted all the masses to the grams. Well and good. The next thing is to find how much of this carbon here. I mean, how much of this carbon dioxide is carbon and how much of this um, water is hydrogen. Okay, so let's do that. So I'm going to say mass of carbon. So mass of carbon, remember the percent, don't forget this percent here. So any mass of carbon dioxide, 27.3 of it will be carbon. So we're just going to say 27.3 over 100 multiplied by the mass of the carbon dioxide. So the mass of carbon dioxide now is this guy. Okay, so that's what I'm going to do there. I'm just going to multiply by 0.04198 grams. So what mass am I going to find? I punch that on my calculator. I'm finding 0.01146 grams. Okay, the next, I find mass of hydrogen in water. So remember, any mass of water, okay, 11.2% of it is hydrogen. So that would be 11.2 over 100 multiplied by the mass of water is this guy. So that is 0.00645 grams. So punch this on your calculator. Okay, I'm finding 0.0007224 grams. So this is the mass of hydrogen. This is the mass of uh, carbon. Okay, so remember, this compound or this acid contains carbon, hydrogen, and oxygen. Okay, so it means that when I add the mass of hydrogen, okay, the mass of carbon plus the mass of the oxygen that I don't know, I should get this mass here. Okay, because it's made up of three things. So here we have to find the mass of oxygen. So how do we find the mass of oxygen? We just subtract the sum of the mass of carbon and hydrogen from the mass of the whole acid there. Okay, so of course we have to use this one here, which is in grams. So that was the mass in grams there. So we're just going to say mass of oxygen is just going to be equals to the total of the acid minus the sum of these two here. Okay, so that would be 0.1164 plus plus what? Plus this guy here. So 0 plus 0.0007224. Okay, so I just punch this on my calculator now. So the mass of oxygen will simply be 0.00768. Okay, so I'll find now the masses of carbon, the mass of hydrogen, and the mass of oxygen. I found everything. All right, so we can now find the empirical formula. So I'll write the masses here. So carbon, it is 0.01146. Hydrogen, it is 0.0007224. Then oxygen, it is 0.00768. Okay, let's find the empirical formula now. So as usual, we start from element. So the element have carbon, hydrogen, and water. And oxygen. And then here I have the masses. I don't have the mass percent, so I can use those. Okay, but if you want, you can actually find the mass percent first of all, and then come and use them here. But we're just going to use the mass anyway to reduce the work. So for this one, 0.01146, this one 0.00724, this one 0.00768. So from there, we're going to find the moles. Okay, so I won't write it here, but I'll just write direct the answer. So I'm going to divide each of these here by their molar mass. Okay, so I'll divide this by 12.01. I'm getting 0.0000954. Okay, this is hydrogen. So I divide by 1.01, its molar mass. I get 0.000715. Then this is oxygen. So I divide by 16. I get 0.000477. Okay, and then I ask myself, okay, which one of these is the smallest to find the ratios? So this is 0.009, 0.007, 0.004. So it means this guy here is the smallest. So I'll divide all these here by this guy. Okay, so I'll be doing it direct from the calculator and then just writing the answer here. So also be doing it on your own calculator. Okay, so um okay, so this guy divided by this, I get 2.0000, so I'll just write 2. And then here, okay, I get, if I divide this number here by this, I get, okay, I get 1.4999, so I'll just write 1.5. And then here, when I divide it by itself, I get 1. Okay, so now can we round off the 1.5? No, we can't because it's in between the x.2 and the x.8. So it's somewhere here. So we have to look for a number such that when we multiply all these things, it will give me a whole number or a number that I can round off. Okay, so we said if it's 0.5 or 4.9, or 0.4, if it's 0.5 or 0.4999, we multiply by what number? 2. So I'm going to multiply by 2. So this will be 4, this will be 3, this will be 2. Okay, so that will be the ratios for our empirical formula. So my empirical formula would simply be C4H3O2. That is my empirical formula. Okay, so we're done with that. We found the empirical formula. The next thing is to find the molecular formula. So the molecular formula, we need that factor, right? Okay, so first of all here, I'll find the empirical formula mass. So empirical formula mass will be equals to, okay, empirical formula mass will be equals to what? Okay, so I have 4 multiplied by the molar mass of carbon plus 3 multiplied by the molar mass of hydrogen plus 2 multiplied by 16. Okay, so my empirical formula mass will simply be, if I punch this on my calculator, it's saying what? Okay, 83.07 grams per mole. So this is my empirical formula mass. Okay, so I just have to divide this into the molar mass. But now look at this on B. They haven't given us the molar mass directly here. They've just given us the information that can help us find the molar mass. So they've given us the moles and the mass. So we can use the moles and the mass to find the molar mass. So we know that moles is equals to mass over molar mass. So here we'll do a cross multiplication. Moles multiplied by molar mass is equals to mass. But I just want to find molar mass. So my m star or my molar mass will just be the mass over the moles. So let's find the molar mass. So molar mass will just be equals to the mass, which is 41, divided by the moles, which is 0.25. Okay, so when I do that, I'm finding 166. Okay, so 166 grams per mole, that is my molar mass. So now that I have my molar mass, I can easily find the factor. So factor will be equals to, okay, factor will be equals to the molar mass divided by empirical formula mass. So this guy gives me 1.9999. So I'll just round it off to 2. So it means the factor is 2. So meaning that our molecular formula would just be the empirical formula multiplied by 2. So this will be equals to 2 multiplied by this will be C8. 2 multiplied by this will be H6. 2 multiplied by this will be O4. So this guy here is our molecular formula. Okay. And then this guy here is our empirical formula. All right. So that's all about that topic. Okay. That's all about that topic. I've covered everything that you need to know. And that is required of you to pass any exam or any question that can come under this. All right. So I'm done. Any questions there, guys? Or whatever we've been doing? Any questions there? Okay, so if there are no questions, end here, but I have an assignment for you. This is assignment here. So I've put up the questions, the same things that we are doing, but you can try them out on your own now. So yeah, so those are the questions there. I'll send it in the group so that you have a clear picture, or you can take a screenshot and then you start practicing. Okay. Otherwise, thank you so much for attending. This week is the last week for our free classes. Okay. So our free classes are ending on Friday. And then starting the other week, only the registered members will be allowed into the meeting, and also they will get access to our website. So the website has everything that you need in order to pass your first year. Okay, we have topic lessons, we have videos on tutorial sheets, we have videos on past papers. Okay, and it's a good platform for your learning. Okay, we also have a mobile app for this website. So on the mobile app, you can download the videos and even watch them offline. So you don't always have to use bundles when you are studying on our platforms. Okay, so the website is discretelearning.com. The app, you go to Play Store, you search for Discrete Learning Institute. The app will come. You can create an account there, okay? And then you log in, you register for the course of your choice. Okay, so yeah. All right, so thank you so much and have a blessed night. Okay, so for those who have never seen the website, I can show you here. So just go to Chrome and then you type in uh, discretelearning.com and then you go there. Okay, so if you are new, it will bring something like this. So you don't have an account when it brings something like this. So you go on top here and then you click on start learning now. So you click on start learning and then it's going to give you this platform here. So if you don't have an account, okay, you can simply create an account there. Okay, so you go and create an account here and then just fill in your information. Okay, your name, your university where you're coming from, okay, blah, 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 your email, and then you also create your own password. Then after that, okay, you just come to this page, you put your email there and your password there, and then you click login. Okay, so you'll be able to log in. Now you are inside our website. So the courses for the first years, you can see math, chemistry, physics, biology. Okay, so you can subscribe for any of these courses. Okay, so for example, I was teaching chemistry, so I can go to chemistry for this video. Then you go in general chemistry here. Okay, so in general chemistry, you're going to find topic lessons. So for all the topics that you're going to learn, here there are summarized notes that you can use. Okay, very summarized notes, straight to the point, and like reading textbook, that will just waste your time. Here we have tutorial sheets. Okay, videos for tutorial sheets. Here we have past quiz, test, and exam papers. Okay, and then here we have lab report samples. So you can use this to learn at your own time. Even on the app, it's the same setup. But on the app, you'll just be able to download the videos and watch offline. On the website, you cannot. So, for example, if I go to topic lessons, okay, so topic lessons, you see here that there are a lot of topics in chemistry. So, for all these topics, we have videos, okay, explaining what to do in that topic. And then we also have some notes inside that same topic. So for example, here, this was, I was teaching combustion analysis and empirical formulas. We already have videos for that, okay? So you can go into this folder, empirical and molecular formulas, and then you go recorded tutorials here. You're going to find the videos that we've recorded before. And then there are also supplementary videos here. If you want, you can watch those if you're not satisfied. Then here we have the slides and notes on that same topic. Okay, so you can check here. You've seen the notes here. So you can read these and understand at your own time, at your own pace, even in your blankets. Okay, so thank you so much. This has been Tutor Pro Solutions. Until next time.